Hello, welcome to Chapter 8, Homework Questions 83 through 88. Question 83, use the zero product property to find the roots of the polynomial below. On this question, it appears to me that they've only given you the polynomials. I believe these should be written as equations so that we can find the roots. So we're going to set all of these equal to 0, and then we'll be able to answer the question. So to use the zero product property, on part A, we need to factor it to get a product so that we can use the property accordingly. So let's take 3x squared minus 7x plus 4 is equal to 0 and factor it. Now that we have it factored, we can use the zero product property. When two numbers are being multiplied together that are equal to 0, one of the factors must be 0. So we're going to set both of them equal to 0 and solve the two linear equations, and we get x equals 4/3 and x equals 1. So we used the zero product property. We factored first, then used it to find the roots of the polynomial. And the roots are 4/3 and x equals 1. All right, question B. X squared plus 6x is equal to 0. We could go ahead and try to do the generic rectangle and everything because it is a quadratic and the constant is 0, but we can also recognize that there is a common factor involved here, and that's an x. So we can actually use the distributive property and factor out the x to leave us with x times the quantity x plus 6 is equal to 0, and now we can set our two factors. One of those is a monomial, and that's fine. X is just equal to 0, nothing to solve there. Subtract the 6, and we get x is equal to negative 6. So x is equal to 0 and x is equal to negative 6 are the roots of the polynomial. And then part C. Now part C is already done for us, so all we need to do is set each of these factors equal to 0. So x plus 5 is equal to 0, and negative 2x plus 3 is equal to 0. X is equal to negative 5. Subtract the 3, divide by negative 2. And when you divide it by a negative 2, it is a negative divided by a negative, so that's a positive. So we have x equals negative 5 and x equals 1.5 or 3/2. Question 84. Jamie was given the problem. Find the result when the factors of 65x squared plus 212x minus 133 are multiplied together. Before she could answer, her sister Lauren said, I know the answer without factoring or multiplying. What was Lauren's answer and how did she know? So looking at that again, find the result when the factors of 65x squared plus 212x minus 133 are multiplied together. So this is just working backwards. Once we find the factors, if we multiply the factors back together, then the result should be the original quadratic. So that's why Lauren knew the answer so quickly, is because once you find the factors and multiply them back together, they should be equivalent. So the answer to this question is simply 65x squared plus 212x minus 133. Now, I don't know what the factors are for that, but that's not what the question was asking. It says find the result when the factors are multiplied together. So once we factor it and multiply them back out, we're going to get the original expression. 85. Solve the equations below for x and check your solutions. So you can see on these are quadratics that we're dealing with. The first one is already factored for us, so we're going to go ahead and set the factors equal to 0 using the zero product property. Add the 18, divide by 6, x is equal to 3. And then on the second one here, we're going to subtract 2, divide by 3, and get x equals negative 2/3. So you can leave x equals 3 or x equals negative 2/3, or if you want to write it as a solution set, we can say x equals, with the curly brackets, negative 2/3 and 3. All right, B. Now B we need to factor. It's set up for y equal to 0, but we need to factor this one. So I'm just going to go ahead and write the factors down. Let me go back here and actually write the original problem, x squared minus 7x plus 10 equals 0. So you could use your generic rectangle to figure this out. I'm going to go ahead and write the factors down. X minus 2 and x minus 5 are the two factors being multiplied to give you 0. And then we can set our factors using the zero product property again. Set them equal to 0, add 2, add 5. So x equals 2, or x is going to equal 5. Or once again, we can write it as a solution set x equals 2, 5. 2 comma 5 with the curly brackets. On to part C. So on part C, we have 2x squared plus 2x minus 12 is equal to 0. There is a GCF of 2, so I'm going to go ahead and factor the 2 out. X squared plus x minus 6 is equal to 0, and then factor that. So once again, use the generic rectangle. You will get x plus 3 and x minus 2, and then set your factors equal to 0. Now we have 3 factors, so we should be setting all of them equal to 0, but 2 cannot equal 0. So you're not going to get a solution from that. So you're only going to get a solution from the x plus 3 is equal to 0 and the x minus 2 is equal to 0. So subtract and add, and we get negative 3 and 2. So x is equal to negative 3 comma 2, or once again, you can leave it just like this. And then the last one, D. D is 4x squared minus 1 equals 0. Now this one is a difference of squares, so we don't need to use the generic rectangle if we recognize the pattern. And they're both perfect squares and they're being subtracted. So 2x times 2x is 4x squared. 1 times 1 is 1. And then we need one of them to be a positive, one of them to be a negative, so that that middle term when we distribute is going to cancel out. So now we have 2x plus 1 equals 0, 2x minus 1 equals 0, 2x equals negative 1, so therefore x is negative 1/2. We got 2x equals 1, and if we divide by 2, x equals 1/2. So those are our two solutions, x equals negative 1/2 and 1/2. So that's how you solve your equations, specifically quadratic equations. We need to use the zero product property, find our factors if they're not given to us, and set them equal to 0. Question 86. Sketch each parabola below given the information. So I have 3 graphs here. So part A, a parabola with x-intercepts 2, 0. So there's 2, 0, 7, 0, and a y-intercept of 0, negative 8. All right, on this one, so you can have your x-intercepts, which will help you kind of find the middle of the graph here. So think about right there. So when you go to graph, it'll kind of help you identify what this is going to look like. So there's a sketch of what it could possibly look like. By not having the vertex, we don't know exactly how high it's going to go just by sketching it, though. B, a parabola with exactly one x-intercept, so it's at negative 1, 0, and a y-intercept of 0, 3. And so on this one, if there's only one x-intercept, then that means the graph must touch the x-axis and not actually cross it. Because if it crosses it, like if I try to do something like this, then it's going to have to come back through and it would have a second x-intercept. So since it doesn't, it's got to come down and then touch and go back up. So something similar to that. And then C, the parabola represented by the equation y equals x plus 5 times the quantity x minus 1. So what information does this give us? I'm going to come down here on the bottom and do y equals x plus 5 times x minus 1. So we have the factors. So if we set these factors equal to 0 and we're trying to figure out what x is when y is 0, we can find the x-intercepts. One of those is at negative 5, 0. And then the other factor, x minus 1 is equal to 0, as x is equal to 1. One of the other x-intercept is at 1, 0. So we know we have one at 1, 0, and then another one at negative 5, 0. But that's not enough. We still need a little bit more as to be able to do this. We could find the middle between negative 5 and 1, and that would be at negative 2. So right here would be our axis of symmetry. So that gives us a better idea, but does it open up? Does it open down? What direction are we going? So now that we know that the middle is at x equals negative 2, we know that the vertex is at negative 2 some y value. So we can plug negative 2 into our x values and then find y. So negative 2 plus 5 is 3. Negative 2 minus 1 is negative 3. So y is equal to negative 9. So the vertex will be at negative 2, negative 9. Now we have enough information to be able to graph that. And I graph, but sketch it, because we have just those 3 points. So 3 different scenarios, 3 different pieces of information, but on all 3 we can get a sketch of what the parabola would look like. Question 87. Review the meanings of the inequality symbols in the box at the right. Then decide if the statements below are true or false. So take a look over here. You have your less than signs on the first 2, and then your greater than signs on the second 2. So on part A, is 5 less than 7? That is a true statement. Yes, it is. And if you have trouble with these, look at a number line also. Is negative 2 greater than or equal to 9? No, that is false. If you think of a number line, here's 0, here's negative 2, and here's 9. So negative 2 is less than 9. Is 0 less than or equal to 0? Yes, it is equal to. Is negative 5, and here's negative 10. So is negative 5 greater than negative 10? So negative 5 is to the right of negative 10, so yes, it is greater than. Is 16 less than or equal to negative 16? 16 is all the way over here, negative 16 is all the way over here. So 16 should be greater than negative 16, so that's false. And is 1 greater than 1? No, that's false. It is equal to, but it's not greater than. Question 88. Calculate the value of each expression below using a scientific calculator. So on the first one here, we could use a scientific calculator, but we can actually do this one without, because the square root of 25 is 5. So we have negative 10 plus 5 divided by 5. Order of operations, we need to simplify the numerator first. And then we can take negative 5 divided by 5, which is negative 1. Now on B, you are going to need a calculator, so we're going to approximate this. We can do the bottom 3 times 3 is 9, but then you need to plug that into the calculator and figure out what that value is approximately. And so you can plug in 8 plus the square root of 40, and this is approximately 14.324 and so on. And then divide it by 9, or you can plug the whole thing in. But if you plug the whole thing in, make sure this is in parentheses before you do that. And then you should get a value of approximately, either way you do it, 1.59. And it doesn't say what to round to, so we could also do 1.59 or 1.6. I'll keep it at 5.9. And then on part C, we have 8 plus the square root of all this. We can simplify. Once again, the square root is a grouping symbol here. We need to do everything underneath there, but order of operations underneath there has us first square the 3. And then we have 2 times 3, so that's 6. And then we can add those 3 numbers up. So we have 8 plus the square root of 9 plus 6 plus 1 is 16 divided by negative 4. And so the square root of 16 is a perfect square, so that'll give us 8 plus 4 divided by negative 4. Same thing as A. Add the numerators first, then divide by the negative 4. So this one has a value of negative 3.